Hi, this video we're talking about angle of twist. So think about a shaft and you apply torsion onto it, and we learned about there's a shear stress related to torsion. At the outer edge of the shaft you see the maximum amount of shear, and in the center there's not much shear, it's zero. However, think about angle of twist. When you twist something, there's going to be angle twisting. And to describe how much the displacement is, we are no longer using deformation, like what we did for axial loading. So think about axial loading we did before, when you have forces acting on it, right? And we're thinking about the delta. And a quick recap on that is summation of PL over AE, correct? P being internal force and L being that particular section length. A area is elastic modulus. However, now we no longer have axial loading. We will have a bunch of this torsion. And let's see, I could make a few in there. And then we have a few sections. For example, here I might have exactly how many sections. Let's see, I have this section, first section, and then I will have another section in the middle. I have different internal torque, and then I have another section. I'm choosing this color, it's pretty. So we're gonna have this. So those are three different sections, and then each section gonna have their own internal torque. So in that situation, we're going to describe this displacement not by deformation delta. We're going to use in this one called angle of twist. So angle of twist, and it's going to, this symbol is called a phi, right? In Greek, it's called phi, and phi is going to be equal this T torque, L, the length, and J, polar moment of inertia, and G is shear modulus. And then we're going to also look at each segment and then summation of then add them together. So another quick recap about when do we use positive and a negative for deformation, for axial loading. We talk about if it's in tension, that's going to be cause elongation, positive. If it's going to be compression, then we're going to have negative. How about for phi, for angle of twist? When would that be positive and a negative? That's going to follow our right hand rule. We talk about when we first introduce the torsion. Remember, your forefinger is going to follow the rotation sense of your internal torque, where thumb is, if thumb is going outward, then that's going to be positive. If it's going inward towards the shaft, and that's going to be negative. So that's angle of twist. So I like to think about them side by side. Here you have the axial loading. Here you have the torsion, right? Then let's look at this formula one more time. Then I'm going to define this T. This T here is going to be your internal torque. Again, it's for each section, because each section, like you will see here, red, green, and purple, they have totally different internal torque. And then we're also talking about L. L is going to be the length for each segment or section. Then we also have our J. J, no need to explain. That's going to be polar moment of inertia. And our G is going to be our shear modulus. Okay, so knowing that, now I'm going to look at the unit. Okay, so angle of twist, phi, since it's described the angle is in radians here, so we're going to use radians. Radians basically is no unit. Okay, so the left hand is no unit. So hopefully the right hand is going to be no unit. So the torque we have over here, torque, we're going to, if it's in SI unit, the torque is going to be force times moment of arm, Newton meter. And L is going to be the length of that segment. That's going to be meter. And J, polar moment of inertia, it's meter to the power of fourth. And G, shear modulus. A modulus is basically, remember you have the stress strain curve at elastic equation. If this is going to be shear, so we're going to have tau over our gamma, right? And then that's our shear strain here, and this is going to be our G. Think about shear stress. Shear stress is going to be Pascal, and strain, shear strain is no unit. Then we know this G going to have the same unit of our tau because G is equal to tau over gamma. So now let's put our G here. It's going to be Pascal. Pascal, I'm going to written up as Newton meter square. All right. So in that situation, this bottom one is basically Newton meter square after you cancel out. This top one is also Newton meter square. Voila, you get no unit, right? So basically, this equation, dimension-wise, it works. Now, knowing that, I think the normal procedure for this problem is you will look at those three different sections, red, green, purple, and you find each individual torque, and then you put them together into this equation. And don't forget, we have to consider this sign convention. Earlier in one of the video we're talking about, it's very important to use this right-hand rule to figure out the positive and negative because it's important for angle of twist. Because one thing about it, one segment could be twisted in one direction, one rotation, and the other one could be totally different rotation. In that situation, you cannot add those numbers, those radians together. You have to actually subtract. That's why this sign convention is very important to follow. All right. So I'll see you at the next video when we actually come up with the example on angle of twist. See you then. Bye.